My name is Marcus Brown. I work with MLC CAD Systems. I'm an applications expert, and we're going to go through several different things that you can do inside the SOLIDWORKS product line. And the topic today, the theme, is firearm design. Now, we see a lot of customers that are actually building firearms, building maybe accessories, suppressors, GoPro mounts, just about anything you can think of. And so we thought this would be a great opportunity to kind of show off some of the capabilities inside SOLIDWORKS and show some examples of what it looks like. A little bit about myself. I'm a mechanical engineer by degree. I've been an applications engineer since 2008. I live here in Stillwater, Oklahoma, and I'm kind of I guess you'd call it an amateur lumberjack. But I have certifications in every single product SOLIDWORKS offers, and we're going to cover quite a few of the topics on the different products that are available. We're going to do a design of a component, and just for the component that we're going to work with today, it's going to be a suppressor, and then we're going to take that component and see how that would apply to another design, specifically a design that isn't a native SOLIDWORKS file. So we're going to bring in some non-native files using the 3D Interconnect capabilities to bring in non-native SOLIDWORKS files without having to do that translation. We're going to do some fluid analysis and potentially some structural analysis. We're going to render it up. We're going to see what kind of publishing results we have, because a lot of the stuff that you're creating for these firearms, you're going to sell it because it's sexy. You're going to sell it because it looks really boss on somebody's gun, and so that's where we're going to go. So the first thing we're going to do is just kind of jump into SOLIDWORKS. And I've got a few designs here that I've built, but I'm going to just kind of start from scratch. I'm going to build a suppressor. And as I build this suppressor, we'll go ahead and kind of talk about some of the new capabilities in SOLIDWORKS. Kind of start from the very beginning. So when you start out drawing this suppressor is just going to be, mounted on the end of a gun. You might call it a silencer or something like that. Just draw the shape and dimension the size. Nothing fancy here, nothing special. What is interesting, though, is this new capability of these contours. So you see the contour automatically gets highlighted, and if you hold down the Alt key, you can pick that contour and simply extrude without having to go and choose that option. So this is going to be the main core of this suppressor. So we'll make it about 10 inches long, and we'll start from there. Now, we may need to make some changes to this. We'll use that instant 3D capability to change the size as needed. Let's go ahead and try out maybe a revolved cut for this suppressor. And this cut that we're going to make, we're going to pattern it along, and we're going to create various different kind of grooves in this design. Add a few dimensions here. And the idea here is what we're going to do is create various little baffles, and these baffles are going to create areas where the air can circulate, flow through and around. And real simple, just extrude, or I'm sorry, revolved cut here to create the first baffle area. And then we're going to do a pattern. It looks like the diameter on that inside diameter is way too small. Let's make that a little bigger here. Then we're going to do a pattern of that baffle all the way to the end. And with that linear pattern feature in SOLIDWORKS 2017, you can now use a cylindrical face to create the directionality. Grab this feature and tell it we want it to go up to a reference, which is the other side. Spacing, we'll go ahead and set we'll set our quantity here as like 4, something like that. And so it gives us a total of 4 items, but you'll see the last one is kind of falling off the end. So I'll go ahead and give it an offset, and that offset will allow me to kind of space those in there together. Maybe go 5 or something like that. And you'll see that if I ever make any changes to the overall length, those spacings will automatically update for me. All right, so looking good so far. Nothing real fancy or special right now. We're just kind of doing machine design, right? Anytime you are building a part, you're just kind of going through creating various features to build out all the geometry that you want. Now, we probably need to make this a little bit wider because what we're going to do is add some holes in here. And the holes, looks like this needs to be a little bit bigger. Using Instant 3D, just kind of visualize it. We'll kind of simplify and solidify a lot of these dimensions a little bit later. But I'm going to add some holes here. And these holes are just to kind of open up the bore to these areas. So we'll do a hole through both in that direction. And then we'll do another one over here on the right plane, same diameter. And just kind of cut that through. Now that hole is a pretty simple hole, but I do want to go ahead and copy this other pattern. An easy way to do that would just be to drag these cuts above the linear pattern in the tree. Just reorder that tree. Change my or edit my feature and simply add those features to this list of components that I want to, features that I want to pattern. As we keep going along, this thing needs to be mounted on the gun. So there's going to be kind of a boss down here where we're going to need to thread it. And so I'll go ahead and convert the ID, create the dimension for the OD, and we'll just set the size that we want to do for that threaded feature. For the threads, usually what we do is kind of do like a cosmetic thread. And for those of you that haven't done a cosmetic thread, it's real simple. You just go into Insert, Annotations, Cosmetic Thread, and just kind of specify where you want your thread to go, and it creates this cosmetic feature. Now that works really well, and it allows your drawing to be ready, but what we want to do with this is make it a little bit more accurate, because the thread is going to be very tight, and we're going to have maybe O-rings and things like that intersecting those threads, so the actual shape of the thread is going to be very important. So instead of doing a cosmetic thread, we'll use the new thread feature inside SOLIDWORKS. And this thread feature just goes ahead and creates the actual physical threads on the geometry. Tell it whether you want to do a die or a tap. Specify the size. This is a 1 inch. And we actually want this to be a really fine pitch. And so we'll go ahead and change the pitch to, let's say, 1 every 20 or something like that. Leave it here, and just tell it that we want it to go up to this surface, and we can have it align with the start and the end faces. Just trim that thread back down, and it should give us a really nice result for that thread feature. Looks like we didn't quite start all the way at the beginning, so in some cases you may find that you need to offset that thread a little bit, and the offset of the thread is pretty simple. Just specify the distance that you want to offset it. We'll offset it out to the outside, so you can see that the thread starts quite a bit further out. So that's looking fairly good. Now we've got quite a bit of extra work to do to finish this out, and I don't want to go through every last bit of it with you, but as we kind of go through and build these vents and stuff like that, and create these airflow holes, you may start to ask yourself, well, okay, is it going to be an effective suppressor? Is this going to do a very good job of keeping the air moving and then reducing the amount of sound? So that's where we might want to go into something with a fluid analysis. So the first thing I did is, and I've got a design I kind of started here, I want to go into a fluid flow simulation with this design and see what happens. And in order to calculate the fluid flow through the suppressor, what I did is I grabbed a chart off of the internet, and you can see there's a lot of graphs, time-dependent graphs, for chamber pressure. Chamber pressure is a fairly known and fairly well-studied item, and so what I did is I just specified a pressure coming into the suppressor that matched that chamber pressure plot. And so here's my pressure plot, and it's just got a big spike right around 5/10,000ths of a second, and then it kind of trails off from there. And so I created this fluid flow study, And setting up a study like this is really simple. I'll go ahead and create a new project just to give you an idea of what that's going to look like. So to set up a brand new project, all you've got to do, whoops, let's actually use the wizard here. To set up a new project, we're going to use the Fluid Flow Simulation Wizard. So if you've never used flow simulation, it's very simple to get started. Just run through the various different prompts, set your units, tell it whether this is an internal or external study. You may want to have time dependent so that you can see the actual movement of the airflow and how that flows through there over time. 1/10 of a second should be plenty of time with an output time step of maybe a 10,000th of a second. You could turn on gravity, heat conduction, things like that. It's really quite simple to do. We'll say that this is mostly carbon dioxide that's coming out of here. And the outside atmosphere, we could set it as air or leave it as CO2. Set the ambient temperature. There might be a slight breeze or something like that. And set up your domain to tell it how big you want to calculate that area or what you want to calculate. Now I've done all that in this one, and what we came up with is a few things. We came up with multiple time steps of results, and these various time steps are available to view. So let's say I wanted to look at a specific time moment. I can go back and pull any one of these moments out and kind of look at and evaluate and analyze what's going on. And I can look at the various different components of results. So here, at the very early phases, you can start to see the pressure building up as this thing is kicking through. And this is a 5/10,000ths of a second into the analysis. We're seeing this pressure start to build. Now what becomes compelling is when you actually start taking these results and plotting them over time into an animation. You can really get a good understanding of what's going on and how effective that design is going to be. So I'm going to create an animation of this. And this cut plot, this is just one of several ways that you can analyze and visualize these results, but it's a very good and efficient way to show kind of the distribution of the part, or the geometry. I'm going to hide the geometry so you can just look at the fluid flow, and we'll create a quick transient result. And all we're doing is just using this animation wizard to go through here and create this animation. Now take a look at what happens. So this is the pressure distribution in the model, and I'm going to hit animate across time, and we'll see it actually load the various different plots up. Now at first this doesn't look very interesting because the pressure pressurizes the chamber, which is to be expected, and then very quickly the pressure is dissipated outside past the nozzle. So let's take a look and see what this looks like in the velocity plot. When you jump into the velocity, things tell a very different story. You animate and the velocity just absolutely explodes outside the end of that nozzle. Now we're going to see some recirculation inside the baffles, and that's what we're kind of looking for. That's what we're trying for. But we don't necessarily see this design doing an effective job of moving that. This maybe would be our baseline design, and see if we can kind of improve that from there. So the velocity is a good identifier or a good kind of predictor of noise, but in 2017 flow simulation, believe it or not, we actually have a new parameter called acoustic power. And what this does is it estimates the volume of the output based on the turbulence that's in the model. And so you can see a lot of the turbulence, play that again, a lot of the turbulence is getting captured inside these little cavities, but most of it is kicking all the way through, and we're seeing some pretty loud outputs at the end of the design. And we can kind of start to see about what the maximum is and then use that as a comparison to others. This is not an acoustic study, but we are getting an estimation of the amount of acoustic energy that's being generated by turbulence. So back to the design, let's say that we've got this thing going, right? We're feeling pretty good about the the design of the geometry. We may want to make a few changes and continue to iterate the analysis, iterate the shape, and see if we can kind of understand what we want to do with this. Change a few more things here. So we all know that we can take this information and we can create a really nice technical drawing. I'm going to call this my new suppressor, and I'll create a quick drawing out of it. We'll use our B-size drawing. Set my units here. And we'll import the annotations as we go to make it really quick and easy to just drop in the various views, and all my dimensions should automatically get picked up. Change my view here in the view selector at the bottom right, my view scale. And when you have a situation where the dimensions are all kind of floating around, everybody hopefully knows you can just box select the whole thing and use this dimension palette to just automatically sort and locate and position all those various different components. So that's a pretty quick example of how we might build and then kind of test and see whether or not the suppressor is going to be any good. Now I've got the core of the suppressor done. I'm going to go ahead and create an assembly out of this and build, there's kind of a jacket that needs to go over top of it. So build an assembly and create that new jacket, and that's going to be kind of in context on top of this suppressor core. So we're going to create a new part here in context, just right here on the end of this face, and we'll just convert this edge. And when you convert the edge, if it's an arc, which this one is, this is just a broken circle, you can actually just drag that arc around, and the arc endpoints connect, and it creates a uniform circle with no endpoints to it, although you still have that point available to allow you to connect to it or define its position. So we're going to extrude this as a thin feature going outward, and we'll take it here to this end face, and I'll just double click that end face so that it goes up to next. It's a nice quick surface, or I'm sorry, up to surface. Doing a quick double click does a nice job of quickly setting that end condition and locating the end of the piece. So this is maybe what I'm going to look at as far as my suppressor is concerned. So I'll save this as my suppressor assembly. But I've got a customer that specifically wants to know how this would look on their weapon. So when I go through and I create this design and somebody sends me a design of their weapon, or maybe I go download a copy of that weapon from that firearm from a GrabCAD, I need to be able to put this design on their design. And if they change the design, if they change the accessories, if they change their mind how it's going to go, and they send you a new updated model, you'd like to be able to pretty quickly adapt to those changes. So that's where we're going to look at 3D Interconnect. And 3D Interconnect allows me to simply treat non-native CAD files as if they were native CAD files. Let me show you how it works. Just go in and insert a component. And when I insert the component, I go to browse for that file of where I want it to be found, and the files of type list shows you all the different files that you can open. And we're talking CATIA, Pro-E, Solid Edge, Unigraphics, Inventor, you know, all kinds of stuff. And I've actually gone and downloaded this model here, this assembly model of a Colt M4A1. And when you bring it in, it's just like bringing in a normal assembly. You don't have to convert it. You don't have to go through import diagnostics. You simply drop it into the assembly. Now, if you want to, you still have the ability to kick out a dumb solid and then maybe do feature works to reverse engineer that. The old functionality is still available, but this new capability makes it really nice and handy. So there's my, whoops, somehow didn't get that dropped. We'll go grab that SolidWorks or that Inventor assembly again. And we'll get it in there. Now it's going to link back to the original file. So if the customer does send me an updated geometry file that's native, I can simply update that file and it'll parametrically update my design. Very much like how I did an in-context edit for that jacket of the suppressor, I can also do an in-context edit or in-context design feature to this native Inventor assembly. So it's a .iam, and here's these various .ipt files. We'll also put in the new suppressor assembly, and we'll see what this looks like. Now that we've got it all on here, boy, it kind of looks kind of dumb, doesn't it? I had my mate and start putting it in there. We really are going to need to make some changes. This thing just looks ridiculous on the end of this part. Customer says, yeah, that looked good, but once I got a scale of it, it really made me change my mind. And for anybody who's ever bought anything online and got it and then you realize, well, that's way smaller than I thought it was on the eBay picture, you'll know what I'm talking about, being able to make sure that your size is correct. So let's go and make a change real quick. Nothing fancy, nothing special. We'll just come in here and change the overall OD. Instead of 2, let's go like 1.25 inches. And we'll see if we can make this a really nice, small, thin component. This diameter, we'll make this 0.95. And this is where we're going to start to blow this thing up again. Oh, no. So that looks pretty good. This guy's definitely too high. So you can grab that cut and just kind of pull on it. So for those of you that don't use Instant 3D or haven't seen Instant 3D, you see it's very easy to go and make these changes to this design. Now if we go back to this suppressor assembly, we should see, oh, and I broke the in-context relation because I saved it as. It's a good tip here. Make sure when you go and create in-context relations, you actually save your assembly before you go and start building your in-context relations. Yep, I don't need to know that. Okay, it's not happy about this. So there is a setting that allows you to decide not to allow in-context relations to multiple components. And so my computer's kind of yelling at me, telling me, hey, you need to fix that. So probably what I need to do is delete those in-context relations and then go back and redefine that. But if we look at the retrofit assembly and take a look and see, the customer's feeling a lot better about how that looks. So now let's kind of start talking about actually selling this on our website, right? We want to make sure that people understand what's possible with this, what it's going to look like from all sides, what kind of finishes are available. So I'm going to start adding some materials. Let's do a brushed steel on this. And when you apply a material to this part, it may not be exactly like you want it. And so I'm going to show you kind of how I would approach changing the appearance to make it look right. So I applied my base part. So that metal, that brushed steel has its own color scheme. It has its own sheen and shine to it. This one's going to be a little bit different. It's going to be a black, a really dark primary color. But I'm going to use kind of a weird iridescent orange, and it's going to create this really wicked effect. This is some expensive paint, but it looks amazing when it's on there. And if you go into the advanced, you can not only create kind of this iridescent design, you can also add additional custom finishes. So for instance, you might do like, my favorite is diamond tread plate, although I think diamond tread plate would look a little bit goofy on the end of a suppressor, although it looks pretty sweet. Looks pretty nice, right? I'm actually going to keep that. That looks good. And then I can take that geometry or that appearance, if you've got that appearance in more than one place, and you can kind of copy and paste it to another design. We'll try pasting that to this part here. So that looks fairly cool. I'm feeling pretty good about my design and what it looks like. So now what I'd like to do is start rendering it. See what I can do to kind of market this to the world. Now, 2017, sees the introduction of Visualize. You can install it with 2016 if you prefer. It does require a separate download, but in 2017 you have the ability to turn on the photo view or the Visualize add-in. So I'll turn that on here, and it doesn't do much. I mean, it's not the most complicated add-in in the world, but basically what you're doing is just quickly exporting this geometry over to the Visualize environment. And it's real simple. It's just an export simple or export advanced. And if you export simple, it's just going to group everything together based on geometry, or I'm sorry, based on appearance. So for instance, if you have those two parts with that diamond tread plate, they'll be grouped as one. And if I decide to adjust the appearance inside Visualize, I just need to adjust them as a group. They'll both adjust together. So you're not, oh, I forgot these 3 parts, or I forgot those 2 parts. They come over grouped. If you export advanced, everything comes in with a normal SOLIDWORKS hierarchy, so you'd have to go in and grab all the parts and pieces that you need. Now, Visualize, if you've never used it, has a very powerful rendering engine, and it can use the cores of your CPU, but it can also use your graphics card to accelerate the rendering process. And there's some cool tricks and cool features. You can make some advanced camera angles, set your scene as being something very accurate environment image. Looks like somebody's got a gun in the kitchen. Set your image backgrounds, or even just apply your appearances. So if I wanted to just change this entire thing over to a red painted gun, it's a very simple drag and drop operation. This suppressor component needs to be a different color. That looks pretty good. Now right now I'm on preview mode, so it doesn't look the greatest. So if I click it over here to one of the render modes, you'll see it creates a much more accurate solution, or much more accurate rendering. And as you rotate, you'll see that it kind of rebuilds the render and kind of recalculates what that's going to look like. Now this is going to give you the ultimate level of realism, and it doesn't require a tremendous amount of effort or skill to create a high quality render inside Visualize. But one of my favorite things to do with Visualize is to utilize some of the capabilities in Visualize Professional. Now Visualize Professional is just like Visualize Standard, and Visualize Standard, by the way, comes in SOLIDWORKS Professional. But Visualize Professional allows me to kick out additional output types. And probably my favorite one, there's 2 of them that are my favorites. There's these virtual reality environments. And I'll show you some real simple examples of what that looks like. But to do that, you go into the render and you specify how you want it to be rendered. The 2 that I'm looking at are panoramic and VR. And with VR, what you're effectively doing is rendering it a bunch of times from a bunch of different angles, and then it creates a web page. Now, with Visualize Professional, you also have a nice render queue, so you can set it up and hit it and push it to the queue so that you can keep working and keep setting up new studies and new render images and new scenes, and keep experimenting while the render queue is kicking off in the background. So let me show you what this looks like when you're done. So here is an example of a firearm that was rendered in that VR mode. And this is on a web page, an HTML file, and it completely gets generated by the software. But if I drag this image around, you can see that this thing is, you can kind of rotate the model. Now this is not a 3-dimensional object, this is just a whole series of 2-dimensional images, but it really gives the illusion that you're kind of in, around, and looking at and rotating this design. When you do a virtual reality one, it's going to be a little bit similar. The virtual reality creates a 3-dimensional sort of spherical image, like an HDR image, and then you can look around inside of whatever item you're in. I have an example of that. I'll pull that up too. And these examples, if you're interested in kind of accessing these, just let me know. I'll make sure that my contact information is there at the end. But I've got these hosted on a web server, and you can come and look at these. So this VR, or this panoramic view, is this 3-dimensional object, and inside of a browser, you can go around and look at this environment. So if you're building something you can stand inside, you'd want to do it as this panoramic, and if it's something that you want to rotate or hold in your hand, you'd do it as a VR. And these look great on mobile devices, by the way. So now that we've got this thing going, we're feeling pretty good about how this is going to behave. This is where we may want to start looking at things like structural analysis, right? Take a look and see what the strength of this design is going to be. Perhaps we have a situation where, I'm going to suppress this thread just to make it a little easier to mesh. But let's say we have a situation where somebody's going to be twisting this or pulling on it or something like that. You'll notice that throughout this entire system, the only time I left the environment, the only time I left the SOLIDWORKS user interface was when I was in Visualize. And that's because it's possible that you may want to have somebody else deal with the marketing images and the marketing imagery and that kind of stuff. It's very easy to just give them that interface, install it on their machine, kick them off, put them in their corner, and let them get to work. But simulation is very simple as well. Very much like flow simulation, you just tell it what you know, and it'll tell you the rest. So we're going to make this part out of, let's do an alloy steel. And we're going to hold on to it here at this end. This is just a really simple, basic analysis. Just hold it at the end, and then we're going to assume that somebody's coming up and hitting it on the end, or maybe you've dropped your weapon and it landed on the suppressor. So we'll just assume that we have some kind of a force here of, let's throw it up, 100 pounds on it. The idea really being we just want to look for the weakest points, or we want to look for weaknesses in the design, because those weaknesses are going to cause potentially cracking and other failures. Now this can also be done with a thermal study. We can run the thermal analysis, see what's going on with the heat as this thing heats up, and it is definitely going to heat up, to see what that's going to do with the assembly. We don't want it to crack as this thing heats up, and the heat just gets intense in these designs. So the thermal aspect of it is going to be very important to handle. Looks like we have possibly some stress concentrations or some stress issues around these holes. So when we go to actually finalize the geometry, if we know that's where the hole wants to be, we may put a little bit of extra time and effort into optimizing the shape to make sure that the stresses are handled correctly. So at this point, we're getting to where we've got manufacturing drawings, we've got rendered assemblies, we've got a bill of materials, we've got stress data, we know what the sound is going to be, and we can start to compare designs and optimize those designs. We can put it on a website and start selling it to some customers. It's a pretty powerful suite of tools for being able to work with really any industry, but we're seeing a lot of activity in the firearms industry.